We have already used the number line to represent numbers like natural numbers, whole numbers and integers before. And it is very helpful to represent numbers on the number line if we want to really have a idea about their quantity and to compare any two numbers, right? So we can imagine a straight line as the number line, and we can mark any point on the line as 0, and then we can take equal lengths to represent integers. Here if I take suppose 2 centimeters to represent one unit or one integer, so this will be 1, 2, 3 and 4, and on the left side we would have negative numbers. So if I write, this would be 0, 1, 2, 3, 4 and so on. Right. Now obviously integers can be easily represented. Even rational numbers can be easily represented. If I have the number 3 by 4, what I can do is I can simply divide the space between 0 and 1, and using the scale I can equally divide this into 4 equal parts. So the third portion will be 3 by 4, something like that. But what about irrational numbers? We know that irrational numbers cannot be written in the fraction form, and even the decimal representation is non-terminating as well as non-recurring. For example, we have the square root of 2, which we know is an irrational number, and the decimal representation is approximately 1.4. Obviously the decimal digits are non-terminating and non-recurring, but approximately 1.4. So again we can easily represent 1.4 if we divide the space between 1 and 2 into 10 parts, then the fourth part will be 1.4. This is an approximate representation, but if we really want to do it in a very accurate way, there is a method to do that using the properties of a right angle triangle and using Pythagoras theorem. So let us take point where we marked 0 as O and point where we marked 1 as A. So 0 OA is one side of the triangle, and then I construct another side of the triangle with the vertex O with 1 unit length. So 2 centimeters equal to 1 unit, we assume that. So this point, let us say B. Then if I join OB, OB will represent a length of root 2. How exactly? So this is our 90 degree over here. OA is 1 unit, AB is 1 unit. That is how we measured it, right? So according to Pythagoras theorem, OB is the hypotenuse. So the square of that will be equal to OA square plus AB square. That is 1 square plus 1 square, which is simply 1 plus 1, which is 2. Now OB square is 2. Therefore, OB will be the square root of 2, right? Taking root on both the sides, OB will be exactly square root of 2 units. Now if we want to represent on the horizontal line the value of root 2, what we can simply do is take 0, the point O or 0 as the center, and measure the radius as OB. Taking OB as the radius, we continue to draw the arc downwards, which will meet the horizontal number line at, let's say, this point we mark as B dash. So B dash will represent square root of 2. Exactly, not approximately but exactly. So OB dash will be equal to OB because they are the radii of the same arc, and that is root 2 units.